Hello learners, today we are learning about redox titration. This is phase 3. The question says like this: you are provided with 10 gram of potassium manganate 7 containing 250 centimeter cubic of solution labeled as solution A. So the other solution we don't have anything. Iron 2 ammonium sulfate containing labeled as solution B. We don't have mass, we don't have volume. So such kind of question, how do you solve it? When one of the questions you are given its mass and its volume, another solution you are not given anything. So that's what we call it phase 3. So now let us see how we can solve such kind of problem. So procedure, we have filled the burette with potassium manganate 7. Procedure 2, using a pipette, place 25 centimeter cube of solution B in a clean conical flask. Then you titrate solution B against solution A and you fill the table. The final reading of the table, the final reading of the burette is here 15 centimeter, here 15 centimeter, here 15 centimeter. The initial reading 0.0, 0.0, 0.0. So volume of solution A used is 15 centimeter cubic, 15 centimeter cubic, 15 centimeter cubic. So if you want now to understand this concept is the one that they bring especially during a national exam. They will give you one of the solution, its mass and its volume. Its volume and its mass. The other solution, they will give you nothing. They will give you nothing. Yes, they will give you nothing. So how are you going to solve such kind of problem? Let us see the questions. So question number 1 obviously asks calculate the average volume of solution A used. To calculate the average volume, we have here 15, 15, 15, 15. You add all 15, divide by 3, obviously. 15 plus 15 plus 15 plus 15. When you add the 315, you divide by 3, you will get 75. Then 75 divided by 3, you will get 15 centimeter cubic of solution A used. Out of 250, we have used only 15 centimeter cubic of that solution A. So question A, that's how question A you solve it. Question B, the concentration in gram per liter of solution A. The concentration in gram per liter of solution A. How do you solve that? It's very simple. You have the mass, which is 10 gram. You have the total volume, 250. What about 1000? Then this is what you say, 10 gram is equal to 250. What about 1000? Then you cross multiply. 1000 times 10 divided by 250. Then when you cross multiply, you get 40 gram per liter of solution A. So that's how you calculate concentration gram per liter, by equating the mass given and the total volume. What about 1000? So that's how you solve part B. We have part C, concentration of solution A in moles per liter, given that potassium manganate 7 K is equal to 39, manganate is equal to 55, and oxygen is equal to 16. So to calculate concentration of solution A in moles per liter means the molarity. Molarity can be calculated by C. Molarity is equal to concentration in gram per liter over RFM. So already you have the concentration in gram per liter here. You have here, you have obtained part B. So what you need only to get is the RFM. RFM of potassium manganate 7. Potassium K 39. We have here 39. Then manganate Mn is 55. Then we have oxygen O 16, but we have 4 oxygen here. 4 oxygen, 4 times 16, 16 times 4. Then you rewrite it again, 39 plus 55 plus 16 times 4, which is 64. When you add all of them, you'll get 158. Therefore, molarity is equal to concentration gram per liter, which is 40 gram per liter over 158, which is the relative formula mass. You'll get 0.25 molar of solution A. So that is how you calculate the molarity. Next we have solution question D. D is asking the number of moles of solution A used. To calculate the number of moles of solution A used, you have the molarity, which is 0.25 that we have obtained right now. You have also the volume used, which is 15 centimeter cubic. What will you do? 0.25, which is the molarity, is equal to 1000. What about 15 centimeter cubic? Simple. So here we have 0.25 moles is equal to 1000, which is the molarity. 15 centimeter cubic, which is the volume used. How many moles used can it produce? Then you cross multiply 15 multiplied by 0.25 divided by 1000. Then here you get 0.00375 moles of solution A used. Then that's how you do it. Part D, I hope you have understood it. We have part E here. Part E is a little bit unique to you. This is where I wanted to emphasize more. The number of moles of solution B used. If you have the number of moles of solution A, how do you get the number of moles of solution B used? You write equation. So that equation is called ionic equation, and it's a very complex equation. During exam, you have to summarize it overhead. So you write an ionic equation between potassium magnesium 7 and iron 2 sulfate. How do you write that equation? So very serious. We have you write ionic equation, manganate ion plus H plus means this is H represents acid, because potassium magnesium 7 cannot react ammonium iron 2 sulfate without being acidification. So acidification means we have to add acid, especially sulfuric acid. So this H now therefore represents the ionic part of the acid. 8 molecules of hydrogen ion, which is sulfuric acid, plus iron 2 sulfate. Then you get manganate ion, manganate 2 ion, iron 3 sulfate, then water. Here there is a reduction and oxidation. We see that iron 2 is oxidized from iron 2 to iron 3 here. Charge, you see the charge is increasing from 2, here it was 2, it's increasing up to 3. So that means it's undergoing oxidation. Iron is undergoing oxidation, where manganate is undergoing reduction. So the charge is reducing from negative to 2. That means it's undergoing reduction. These things you learn in electrochemistry form 4, inshallah. Now when you write the equation like this, you have to balance it. When you balance it, the mole ratio of manganate ion is 1, because we don't have anything here. Then the mole ratio of iron 2 ion from the reactant side is 5. So the mole ratio is 1 to 5. Then since you have the number of moles of the manganate ion or solution A, then you'll say mole ratio 1 is equal to 0.00375, which is the number of moles of solution A, which is potassium magnesium 7. Then what about 5, which is the mole ratio of iron 2 sulfate? How many moles will it be equal to? Cross multiplication. This 5 you multiply this number of moles, then 1 you divide it. 5 times this one divided by 1. This is what you get. You'll get 0.02 moles of solution B used. So that's how you calculate it, the number of moles of solution B. Okay, that is E. We have F, then the concentration of solution, the concentration of solution in moles per liter of solution B. So that means they are asking us the molarity of solution B. To calculate the molarity of solution B, simply you will not even use the previous concept, because you will not take this RFM, all these things, you will not take it. However, they wanted to confuse you. So this is what you do. Since you have the number of moles of solution B, then you also have the volume of solution B used. The volume of solution B used is 25 centimeter cubic. The number of moles of solution B used is 0.02 from the equation. So they are equal. Then you say what about 1000? You will say what about 1000? 0.02 mole is equal to 25, which is the volume used. What about 1000 to get the molarity? Then you cross multiply 0.02 moles times 1000 divided by 25. Then you get 0.8 molar of solution B, which is ammonium iron 2 sulfate. That's the molarity of ammonium iron 2 sulfate. So if you have any question, please, you can share with me in the description part. We have finished the practical part. We have done simple titration, we have done back titration, we have done double titration, we have done redox titration. Our next lesson, I'm going to summarize all of them, and I wanted to give you a general hint of how you are going to handle it during national exam when all of them is brought. One of them is brought in the exam. So I will summarize them. Then after that, we'll start molar gas volume and we conclude mole. Thank you.